and welcome to tonight's webinar, Mathematical Methods Exam Readiness, hosted by Texas Instruments Australia. My name is Božena Graham, and I will be your host for tonight's webinar. So it's my pleasure to introduce our first panelist for tonight, Craig Brownie. Hello, Craig.
Good evening, everybody.
Craig is a TCube instructor and VCE mathematics teacher currently at St. Joseph College in Geelong, with many years teaching experience at all three VCE levels, further mathematics, mathematical methods, and especially mathematics. Our second presenter for tonight is Frank Moya. Hello, Frank.
Hi.
Frank Moya has been teaching mathematics for over 30 years at all senior levels, and recently he has worked as a mathematics consultant and is involved in teacher support and curriculum development. So Craig will be the first to present, so welcome, Craig.
Thank you very much. Good evening, everybody. What I thought I would do with you tonight is run through with you some applications or introduction to the notes page applications. I find these a very useful resource, and in some respects I think possibly perhaps underused a little bit, because from my point of view, I guess from the practicality of our students answering questions, anything that can be done relatively efficiently should be done that way, so it gives them a bit more think time in some of the more challenging questions. And so tonight, first of all, I'll go through a bit of an introduction on how the notes pages can be used and set up, and then show you some of the things that some of my students are doing in class at this time of year when they're practicing for exam 2. So if you give me a little bit, I'll just go to the very start of this file. I should have had this up and running before. Okay, so first of all, I'll show you effectively how the notes page can operate. For a basic example, if I want to enter some information, for instance, 2 points, if we think about our coordinate geometry, I press Control and M on a notes page application, a maths box will occur, and if I press X1 to define, if you like, the X coordinate, and then Control and the Assign button, which is just above the template button written in the blue colour there, I'll give that the value 2. And as you can see, the variable x1 is highlighted in blue. I will now find y1 the same way. So y1, 2, and then we'll go x2. We'll try 5, y2, 5. So at the moment, I've basically constructed, I've defined a pair of points. It is possible to perhaps format this a little bit. If I put my cursor beside the Y1, notice I've got my cursor inside the maths box there, but if I just, if I'm a little careful with my mouse and position it appropriately, it's now outside the maths box. And if I hit the delete key, I can actually format my screen a little bit. So if you want to minimise the space being used on the notes pages, we can do that. If I want to work out the gradient connecting, of the line connecting these 2 points, I will again use the Assign button on my calculator, open up the fraction template at y2 minus y1 over x2 minus x1. If I now press enter, it does the calculation for us. Now the beauty about a notes page, which is a little bit different to a calculator page, is that effectively this is live. So if I make a change here and give that the variable a, for instance, I've now got the gradient in terms of a. So I can make any changes I like to these, and when I press enter, I get the result automatically updated. Now if I perhaps do another example using this information, I'll change back to what it was, 3. Oh, sorry, I'll change that to a 2 and make that 5 again. So perhaps we'll go look at the distance between the 2 points. So the distance equals the square root of my bracket x2 minus x1 squared plus y2 minus y1 squared, and there's the exact distance calculated. If you wanted that as a decimal approximation, if I highlight that and press Control Enter, I get the decimal approximation. If I press Enter again, it toggles back to the exact value, and that's the same for basically any of these calculations. If I do the same up there for the gradient, it will do the same thing. So Enter goes back to the fraction 3 on 2. Control Enter back to the decimal approximation. So that's basically how that's a basic example of how a notes application can be set up. Perhaps more importantly is how we can set these up so we can do a lot of our function algebra and calculus. So that's what I'm going to do on this next page. So first of all, I'll define a function to have a play with. So again, if I press Control and M to open up a maths box, I'll define the function f of x. With my cursor over if we see it. Control and assign. And we'll open up a fraction template. X cubed over 600. Oops. So I've defined a function. What I'll do is also define a second function, same way. So Control M to open up a maths box. There are a pair of functions defined which are fairly similar to a pair of functions that were on last year's exam 2. If I would like to, for instance, find where these two lines cross and the coordinates, I've got some options available to me. I could use solve, and so as I've posed a question here, could we use solve or zeros? So let's have a look at the difference. So if I open up another maths box again, now if we want to access the all the famous menu functions on the calculator, there is a slight difference when we use the notes page application. If I press the menu here, the initial menu menu choices are a little bit different to what we're used to seeing, but as soon as I go to calculations, this menu is the one that most of us will be familiar with. So if I go to algebra, I can then go to solve and choose the solve feature on the calculator. So if I solve f of x equals g of x, comma x, I get the points where those two graphs cross. The difference between that and zeros, so if I go and find zeros, again menu, calculations, algebra, and zeros, which is option number 4. What we do is you need to set up an expression that you would make equal 0 to actually solve it. So if I actually wanted to, if I rearrange this expression up above here in blue and move b of x over the other side, that would be f of x take away g of x, or transposed it, comma x. And so what the calculator does is it sets that expression equaling to 0, which, as you can see, I get the same results, but they are displayed in a list as opposed to set out separately as the solve does with the x equals in each case. The advantage of zeros is by doing this. If I defined these as that function as x coordinates, so I'm basically giving those results the variable, the x coordinates, what I can now do is find the corresponding y coordinates by now substituting those into either f or g. They're the corresponding y values. So back to what I was saying before when I first introduced my purpose of doing these notes pages. If I make some sort of change, if I need to change the function for some reason or other halfway through the question, I might want to make this 100 instead. Everything underneath gets automatically changed accordingly. And so it's a slightly more efficient way in perhaps getting results down, some of the more basic results down that are earlier on in a question. We also shouldn't forget that once we have actually defined a function, either f of x or g of x like I have, then if we have a graphing page open, we can get our graphs displayed fairly quickly as well. So if I hit, now I've got this open, so I hit Tab or Control G to open up the entry bar and type in f of x, and hit Tab again, g of x. Of course, we're looking at a screen that doesn't show us very much, but hopefully by now our students have done enough examples where they need to realise they need to zoom in appropriately. So I'm just grabbing the axes there and quickly finding our two graphs, and quick analysis would show that our results down here. So here's my first, the middle coordinate is the x coordinate negative 29 and 44.49 or 5. I have go back over to here, we can in fact check the fact that that would be that point there. So we move on. Another example where these notes pages are quite effective, possibly looking at doing some questions involving discrete random variables. So what I'll do is I'll define a variable. So again, to do any maths, we have to open up a maths box. So Control M, open up a maths box. So the values of x in our discrete random variable table. B. Now, when we're actually doing it this way, we need to display our results in a list. So if I press Control and the bracket button there, as you can see on my screen, you'll notice that the brackets have been displayed. What I might do is just make it a little bigger so you can perhaps see it a bit easier. I'll try 0, 1, 2, 3. So as you can see, my separate values for the discrete random variable are separated by commas, and I'll press enter. Now I'll define a variable called p for the probability, And again, the values of for the probability values for each of those corresponding values of x have to be displayed in a set of curly brackets and separated by a comma. I'll press enter. I have got now basically, here's my discrete random variable table. So there's the first value of x, and there's the corresponding probability. Second value of x and the corresponding probability. From there we can make a few checks. If I sum, so I've just typed in the word sum, all the values in the probability, it equals 1, which of course we would expect. But what's also pretty cool, if I could actually turn around now and ask the calculator to work this out, the sum of x times by t, which is 1.5. So 0 times by 1/8 plus 1 times by 3/8. Follow the pattern through as we would by hand, and we get an answer of 3 on 2, or 1.5. So if we want to work at the expected value of x squared, we did that. There we have it. And so again, it's a nice quick way of getting some of these key results that students may actually have to do in an exam situation. One last thing I would like to talk about in perhaps setting up our files for the exams at the end of the year is using problems within a file. And so the important thing about doing that is that any variable that is defined in problem 1, and so if you're not quite sure what I'm talking about, so far I'm only using the one problem, and and that's called problem 1, and at this stage I've got 5 pages. And so if I hit the var button over here, we will notice that I've actually created quite a lot of variables within this particular problem. If I press doc, insert a new problem, and either create a notes page or create any other page we like, so I'll go with another notes page. If I press Control M, if I go and in fact try and use F, notice F is not bold, F of X. I'll just type in F of X. Nothing's come up. That's because F of X, which was defined in the previous problem, is not now recognised in this new problem. And if that will also be further verified if I hit the var button here, within this problem there are no variables defined. And so if we look at the practicalities from exam 2 point of view, a file can be set up where, for instance, a student might want to use problem 1 as the multiple choice section of the exam, and then set up problems for each of the extended response questions. That means that if a student gets stuck, they can go on with the next problem and not have to delete all their work. And I've heard stories of students doing that in the past, and there's no real need for it. They're wasting a lot of time when they have to go back and rehash their work. And so what I thought I would finish off my part of tonight's session would be is just to show you how my students have basically scaffolding their exam 2 file. And I guess what's really important is that once a file like this is set up, it's really important that students do practice using it in exam conditions when they're practicing their exams at this time of year. So if I click on this first file here, exam 2, and typically I've gone right to the last problem and not the first, so I'll just scroll across. Okay, so here's the first problem, and you can clearly see that we've called this the multiple choice section. So this is where obviously we're going to be doing quite quick stuff that involves quick answers to multiple choice questions on a large part. So if I define a problem, define a variable for instance, so control M, open up a math box, I might want to go f of x dot equals e to the 2x minus 3 or something. I've defined a function, and so I may wish to evaluate it, f of a or something. That's okay. I may wish to in fact find the domain for a multiple choice question, so f of x comma x. So hopefully that's no surprise. Now if we go to the graphing page here, hit the tab, there's the function graphed. What possibly people aren't maybe not 100% aware of is this new feature in the current operating system where we can graph relations. And this is quite a useful tool when it comes to graphing the inverse of a function. So if I ask the calculator to do this, x equals f of y, press enter, I now have the inverse graph of what I've defined, which is a nice cool feature, and again, if a quick way of in fact getting the picture of the inverse. So as you can see, this first section is pretty much would be set up. You wouldn't have a lot of stuff on there. There's nothing stopping a student opening up a calculator page. This is a calculator page. So from there, remembering the fact that once something's been defined, there's nothing stopping us going in and accessing all our other tools available to us, whether it be algebraic or calculus functions, to answer questions. But from there, if I move across, my next problem, so you can see here now, problem 2 is the first extended response question. And so quite typically, what a lot of my boys are doing is basically just having something as simple as a pair of functions predefined, or at least some boxes predefined, and so from practice exam to practice exam, they're starting off with that. From there, they're reading the question, deciding, okay, I might have to solve where those equal. What some students are doing is they're deciding, yes, this is something I have to do a lot of, and so they're actually keeping this particular maths box from practice exam to practice exam, and basically, and naturally enough, from question to question, they're really just changing the functions, and so it's allowing them quick access to getting some of the more basic answers down. Now, naturally enough, we've got they have a graphing page there, which means, of course, if I hit tab, put in f of x, and tab again, g of x, there's a picture of our graphs, whatever they may be, and again, from practice exam to practice exam, they're just simply changing this, which is already there, which means that's automatically getting graphed, and so they're getting quick access to their questions. And so, effectively, when we first set this up, all we really did was, once we created a page like this, if I press Control A to select all that, Control C to copy, Control V to paste it, we don't need that line, so I'll highlight it and press delete. That's ready to go for the next question. And so of course that will change. The last thing I will now do is skip down to the last, and this is probably going to dovetail a little bit into what Frank's going to do, is the last question, the last problem they've got is set up is just some basic probability. So as you can see, I've got the first page here is some DRV and binomial work. One thing to probably be aware of, you don't want too many applications and too many problems open up in one file, so it needs to be lean and mean, otherwise the calculator tends to lag. Creating these files on computer, you don't notice it, but once you start using the files on a calculator, too much information in a file, they tend to lag, so they've got to be a little bit lean and mean from that point of view. My next page here is just simply a continuous probability page. There's a function defined, and then really only need the two maths boxes. First one just basically doing some quick probability calculations, and this one basically solving for some sort of unknown, whether it be finding a median for that point, or if I change that of course to a 0.25, there we go, there's the lower quartile. The next page is basically just a normal distribution page, so just normal CDF, inverse normal, functions all there, so all we really have to do is just change these values. I'll just change that to an 85, and as you can see, the calculation is made. And the last thing is basically just a confidence intervals coming up, so there's the confidence interval page there. If I want to work out the 95% confidence interval for that data, if I just change it to 95% confidence interval, it gets updated there. Or if I change the sample size to 200 instead, whoops, what have we got, a domain error there. Oh, no wonder. Might change that to 600, and we get much more sensible result. So hopefully that gives you a little bit of an idea how to possibly set up some files for your students to answer exam 2. And I think it's time now to hand over to Frank.
Okay, well, good evening everyone, and thank you for that, Craig. While I'm waiting for my desktop to appear, has it appeared yet?
Yes.
Okay, while I'm waiting for that, I'm mainly going to concentrate on the probability and statistics part of the course, the new content, and so I thought that I might start with a brief look at the notation, just so that we're all clear. So P denotes the proportion of the population with a particular characteristic, so that might be the proportion, the proportion of the population who are left-handed, or the proportion of white cars in a car park, or whatever. So capital X is the random variable that denotes the number of times that the characteristic is observed in a sample of size n. So an observation of the characteristic can be called success. And X varies from sample to sample. So X is binomially distributed because you either observe the characteristic or you don't. So in a single sample, there are X successes or observations and n minus X failures. So the lowercase p hat denotes the proportion of successes observed in a single sample of size n. So p hat is x over n, that's small x over n, and capital P hat is the random variable denoting the proportion of successes in samples of size n. So it's a random variable, also varies from sample to sample. And the sampling distribution of p hat, because p hat is a random variable, it has a distribution with a mean at p and a standard deviation at the square root of p1 minus p over n. And those formulas are supplied on the new formula sheet. Now, I was talking to some teachers the other day as to what they would find useful in this session, and a lot of them said, well, the only indication we've got of what exam questions are going to look like for the new content is the sample exam, and the VCEE hasn't supplied solutions to those. However, I'm acutely aware of potential copyright issues, so the file that will go on the website will only have the question number and the solution. It will not have the wording of the question. So the first question I'm going to look at is question 14 in the multiple choice. So an opinion pollster reported that for a random sample of 574 voters in a town, 76% indicated a preference for retaining the current council. An approximate 90% confidence interval for the proportion of the total voting population with a preference for retaining the council is found by evaluating. Okay, so we want a 90% confidence interval. So the information we're given the value of n, we're given the value of p hat, and we want a confidence level of 90%. Now, the confidence interval for the true population proportion is going to be of the form the sample proportion plus or minus the margin of error. Now, the term margin of error doesn't appear explicitly in the study design, so it's not going to be used in the exam. However, the concept students need to be familiar with. And the margin of error is Z times an estimate of the standard deviation of p hat, which we call the standard error. Once again, the standard error isn't required for exam purposes, but the concept is. And Z is the standard normal quantile for the particular confidence level. Now, the reason that we can use the normal approximation in this case is because the sample size is sufficiently large that there are at least 10 successes and at least 10 failures. Now, some statisticians say that that should be at least 15 successes, 15 failures, whatever the case, it's certainly met in this case. All right, so what's this Z value? So the Z value, if we have a 95% confidence interval, the Z value is the value here such that we have 95% in the middle and 2.5% at each tail. For a 90% confidence interval, the corresponding Z value is about 1.64, so you've got 90% in the middle and about 5% each side. So how could we calculate that? Well, we can just use inverse normal. So inverse normal, we're taking into account the fact that we want 5% each side. That's where the 1 minus 0.9 over 2 comes from. If I wanted to work out the Z value for a 95% confidence interval, change that, and it's about 1.96. And so the answer, you'd be looking at the correct option would be the option that is of that form. All right, so that's all very well, but what does that actually mean? And one would hope that by the time that students get to answering exam questions, they've done lots of simulations in order to get a handle on this topic. Okay, so if we simulate a 90% confidence interval, in this case, actually I'll keep going until I get one that's exactly 76. Okay, so here, p hat in this confidence interval is 0.76. So that's the point estimate. That's the estimate of the true population proportion. The margin of error is half the length of the interval, and we've got the endpoints of the confidence interval. Okay, and the intervals will change. I can have different 90% confidence intervals. So let's suppose, for the sake of argument, that the true population proportion was 0.75, 75%. Now, in this case, this particular confidence interval would contain the true population proportion. But this one doesn't contain the true population proportion. So generating random intervals, we see some contain the true value of P, some don't. All right, so in the long run, approximately 90% of confidence interval will contain P and about 10% don't. And however, in terms of interpreting confidence intervals, students need to be aware that once a confidence interval has been calculated, it either contains P or it doesn't. It's no longer a matter of probability. Okay, so that's in terms of understanding. That was a pretty easy question. You didn't have to know very much in order to get the right answer, but I think it is important that students understand what they are doing when they're calculating confidence intervals. They're actually looking at the reliability of the estimation procedure. Okay, now the next question, and once again, none of the wording of the question will appear on the file because I don't want any copyright issues. It will only be the solution. So in this question, question 3, in the extended response, you've got a large company that runs many gyms with over 100,000 members. So you've got a very large population. That's the point of this one. Now, it's been found that a particular exercise that they have to complete, the probability that it's done in less than 3 minutes is 5/8, and a random sample of 20 members is taken. Okay. X is a random variable that represents the number of members who complete the exercise in less than 3 minutes. So the information we're given so far, we're given the value of P and we're given the value of N, and we want the probability that X is greater than or equal to 10. Now, interestingly, that's a 2-mark question. So part of using technology effectively is for students to know that they have to include working and what working they should be writing down when they're answering or when they're obtaining an answer with technology. So I guess relevant working basically show that they understand that X is binomial and that they know the value of the parameters N and P. Okay, so this is on a calculator page. I know N and I know P. So quite simple menu, probability, distribution number 5. Now I can't see binomial, but if I hit the up button, I see that it's E. So the number of trials, 20. Tab, probability of success, 5/8. The lower bound was 10. The upper bound, 20. And we get an answer. And of course, we need to make sure that students know how to round to 4 decimal places. And anyone who has marked VCEE Exam 2 questions know that many students don't know. So it's very important that they write down 0.9153, otherwise they could potentially lose a mark. Okay. So the next one, find the probability that X is greater than 15 given that X is greater than 10. So once again, what I was going to illustrate here was, okay, they need to show some working. So perhaps showing that they understand the concept of reduced sample space would be useful. But the other is the efficient use of the previous calculation. So they already have this calculation here from the previous question. So now if I just set up a fraction template, and if I arrow up to there, it'll paste it, and I can edit that to 15. And if I now Control V, whoops, I'd better copy it first, hadn't I? If I go back to there, Control C, arrow back down, Control V. No, it's not wanting to do it. Control C, Control V, change that to 10, and they come up with the answer. So that was much more efficient than having to go back through the dialog boxes and so on. Okay, so for samples of 20 members, capital P hash is the random variable of the distribution of sample proportions of people who complete the exercise in less than 3 minutes. Find the expected value and variance of P hash. Okay, so I'll store 5/8 as P, and in a math box, doing as Craig showed, so 20, I'll store that in N. Okay, now on the formula sheet, we have that the expected value is P, so that's 5/8 obviously, and we know the variance. Now because I've defined that, I've got the variance as well. Now that was 3 marks, fairly generous, so presumably 2 answer marks and 1 answer for knowing the formula. Okay, so what does that actually mean? Well, if students have been doing their simulations, they would realise that here I've got, in this simulation, I've got 500 random samples at a time, and we see that if I take the average of the 500 samples, it's very close to 5/8. 5/8 is 0.625. That's pretty close, okay? And it will vary, depending on the 500 samples, but it's always very close to 5/8. And so that's the meaning of the expectation being P. And the variance is just a measure of how spread these values are. Okay, so find the probability that a sample proportion lies within 2 standard deviations of 5/8. Give the answer correct to 3 decimal places. Don't use a normal approximation. So this time we want 5/8 plus or minus 2 standard deviations. So going back to here, so what we're saying is for a particular observation of P hash, find the probability that it lies within 2 standard deviations of the centre. Now here these 2 boundaries show the 2 standard deviations, so find the probability that it lies between these 2 boundaries is basically what the question is asking. Okay, so this is what I've got already. I've got, from the previous question, I already know the value of the variance, and I'll actually store the variance as V. So what I can now do is, so P hash is going to be within 2 standard deviations. Actually what I'll do is, I'll hide that for just a minute. So P hash is going to be between P minus 2 standard deviations, or the square root of the variance, and P plus 2 times the square root of the variance. And we get these values, so it's going to be somewhere between 0.408 and 0.84, which is what this was showing back here. Okay, so that's what these values are in there. Now, I want to know a probability. Now, I don't know a lot about the probability distribution of p hat, but I know a lot about the probability distribution of x because it's binomial. And I know that p hat and x are related by n. So p hat is x divided by n, or conversely, x is n times p hat. So if I take these values here and I multiply that by 20, so 20, okay, then instead of having p hat, I've got x. And x has to be greater than 8.17 and less than 16.83. And of course, I also know that x is a discrete random variable. It's the number of members who complete the exercise in a particular time. So if it's discrete and it's greater than that value and less than that one, it must be between 9 and 16. So it's not a matter of rounding, it's more a matter of ensuring that the values are discrete and that the values satisfy the inequalities. Okay, so I can now do the normal CDF again, the same way that I've done before. I'm not going to go and do it all again because it's the same as before, except if I'm doing it in the notes page, as Craig showed, it's a little bit different. To do calculations in a notes page menu, you have to go calculations, and once you select calculations, then you see the same menu that you would see in the calculator application, and then probability, distribution, and so on. And because it's binomial again, that's the reason that I wasn't going to do it again. All right, and of course we need to make sure that students round correctly to 3 decimal places. All right, and once again, this was just to what I was saying earlier. So that's what the result means. That percentage was about 94%. So what it's saying is that in the long run, about 94% of samples, if we were to take many, many samples, about 94% would be between these two boundaries and about 6% would be outside. Right, so the next one, find the probability that p hat is greater than 3/4, given that p hat is greater than 5/8, and give your answer correct to 3 decimal places, don't use a normal approximation. So once again, we want probabilities involving p hat, and I don't know a lot about the distribution of p hat, but I know a lot about the distribution of x. So I can start off by just using the fact that x is n times p hat, and I get 15, and so a p hat value of 3/4 corresponds to an x value of 15. P hat value of 5/8 corresponds to 12.5. However, because it has to be discrete, I need the probability of x is greater than 15 given x greater than 13. Okay, now I've already done a very similar calculation to this in 4.9, so I was going to use this to illustrate efficient use. If I go back to my previous calculation, I should just be able to copy and paste it. So control up arrow, whoops, let's try that again. Let's go back to where I was. Control up arrow, I'll go back to page 4.9, So it's very similar to this calculation. Now, if I want to select all of that on the handheld, all I need to do is to hold down the Shift key and then arrow across, and it will select. By holding down the Shift key, you can select it all, and then Control Copy. I'll go back to page 6.5, I think it was. Yep. Okay, Control V. And all I now need to do is to edit. And bingo, I get my result. And once again, make sure that students would need to make sure that it was rounded to the specified number of decimal places. Okay, which is 3 decimal places in this case. And that's exactly the same calculation which I did earlier during practice, and this time instead of doing it on a notes page, I've done it in a calculator page. You can see it's much the same. Okay, so when they surveyed many of its members, they found that for another exercise routine, it followed a continuous random variable W with this particular probability function. Okay, and it asks to find the expected value of W to correct the 4 decimal places. All right, now, I've already partially started doing this because it was going to take too long to do, but I wanted to illustrate the use of the hybrid or piecewise function template. So if you go to the templates here, it's the template over here. Okay, you can select the number of pieces, which in this case is 3, and you can place both the function definition and also the domain restriction. Finally, it's 0. Now it's 0 otherwise, or 0 elsewhere. Now, else you can find if you go to the catalogue. If you go to the E's and then you scroll down, you will find that you've got elsewhere. Okay, and interestingly, if I now just input G of W, it actually gives me the definition. It knows exactly what what elsewhere means. Okay, now I'm almost out of time, so I'll just do this last calculation. So the expected value is going to be, I'm going to need the integral, so I'll get it, I could get it from the calculus menu, but I'm going to get it from here. So it's going to be the integral from 1 to 5 of W multiplied by G of W with respect to W, and we see that the expected or mean value is just over 3 minutes. Okay, and the next part, which asks if you had 200 members, how many would you expect to take more than 4 minutes? So once again, we're using the calculation we used previously. We can copy that, just do a bit of editing. So we want from more than 4 minutes, so it's from 4 to 5, or actually I could have it 4 to infinity because of the way I defined it. That gives me the proportion. If I multiply that by 200, it gives me the numbers. Of course, that's not terribly useful. However, if I do Control Enter, I can see that it's 52 people. Okay, now This file will be available for you to download but it'll only be the solution, no wording of the questions, which will be available on the website as from tomorrow. And I think that's my time up, so thank you very much for listening.
Thank you very much, Frank, and thank you, Craig, for fantastic ideas and ways how to use TI-Nspire calculator efficiently and how to even prepare using the notes pages and maps boxes and all the interesting questions Frank was doing on new stuff on statistics. After the webinar, you will receive a quick survey, so we would appreciate if you could take time and fill it in. We appreciate your time and comments to improve the way we do the webinars. And you will also receive an email with all the files which were presented in the webinar tonight. If you would like to see what's coming up, if you go to Texas Instruments website, we see that was the webinar tonight, and tomorrow we have examined Readiness for Further Mathematics, the last one in the series, and if you go to on-demand webinars, there are other webinars which have been presented before. We also have a YouTube website with various YouTube videos on different topics, so it is also something we recommend. And lastly, if we go to professional development, you might see what's coming up in other activities, and also Senior Curriculum Inspired is an interesting website here, and because we're looking at mathematical methods, we might just see probability and statistics and files there, and algebra files, functions and graphs, and so on. So thank you very much again, and thank you, Frank, thank you, Craig, and good night.
Good night.
Good night.